Hello everyone and welcome back to yet another video from my channel Interactive Education, running for the best education possible from the student to the student for a better experience. And today we'll be continuing the series on chemical bonding, and we'll take up the next kind of chemical bond, that is covalent bond. Now, the last class we've already discussed the ionic bond. And the ionic bond is basically a bond which is formed between ions, that is charged species. So the bond formed between ions, right? Or we can also say that an ionic bond is a chemical bond which is formed between atoms that can easily lose or gain electrons, right? So an atom can easily lose or gain an electron and form a bond, an ionic bond, right? Metals usually lose electrons and form positive ions. Non-metals usually gain electrons and form anions, that is negative ions, and they come together and form an ionic bond. So that's an ionic bond. So till now we've just discussed those ones which can easily lose or gain electrons, right, based on convenience. But what about atoms like, suppose, carbon? Carbon has atomic number 6 and its electronic configuration is 2, 4, right? Now, carbon has 4 electrons in its outermost shell, right? And it wants to gain 4 more electrons or wants to lose 4 electrons because it wants a noble gas configuration as per the octet rule or as per Bohr-Bury's rule. You need to have a noble gas configuration, or you need to have 8 electrons in your outermost shell, 2 in case of hydrogen. So we basically now go into how carbon forms bonds, right? Now, carbon has 4 electrons in its outermost shell. So it has 2 possibilities. Number 1, it can lose 4 electrons, right? It can lose 4 electrons and form C4 plus ion, right? A C4 plus ion. It can do that. Or it can gain 4 electrons and form C4 minus ion, right? It can form an anion also, but what will it do of the two, right? The answer is that it will do none of them. What does carbon do then? Well, why doesn't it do these things? First of all, let's try to understand. It can lose 4 electrons and form C4 or C4 plus. Well, why would that be a problem? It is a problem because it is difficult to remove 4 electrons from the outermost orbit of carbon. It is not easy. It requires a great deal of energy, and which is not too easy to get, right? So we basically just rule out this option. It's very difficult to achieve. Gain 4 electrons. Well, electrons can be gained by carbon, right? It can gain 4 electrons. So it will have a nucleus. It will have orbits. And in the outermost orbit, it will get 8 electrons. Right? Well, that's good. But if you have 8 electrons in outermost shell, you have 2 electrons in the inner shell, and you have only 4 protons in the nucleus, right? Because proton number will be constant. It's the atomic number. So you have 10 electrons outside, 4 protons inside. So you can guess how much influence and force, electrostatic force, will be exerted, right? So that is going to create instability in the carbon atom. Right? So obviously that's not a way to gain stability. Right? So that's the problem. We cannot give 4 electrons to carbon as well. That is also a problem. So what does carbon do to form bonds and gain stability? Right, that's a good question. It follows the method of covalent bond formation. And now let us look at what this covalent bond is. Covalent bond. Covalent bond. Now, when there are cases when you cannot lose or gain electrons easily and it's not very feasible, we follow the covalent bond usually. And this covalent bond is a chemical bond which is formed as a result of sharing of electrons. Sharing of electrons. So basically electrons are not lost or gained here, they are shared, right? We share electrons, right? So let us take some examples to understand this. For example, oxygen molecule, O2, right? We know this oxygen molecule. How does it form? Let us have a look. Oxygen has an atomic number of 8 and its electronic configuration will be 2, 6, right? So now if we draw its structure, Lewis dot structure, by showing only the valence electrons, that is electrons in the outermost shell. So 1, 2, 3, 4, 5, 6, right? This is the Lewis dot structure for an oxygen atom. We take another oxygen atom. Now note that it needs 2 electrons to complete its octet configuration. Again, this oxygen will have 6 electrons in the outermost shell, so we'll denote them with that. Now this oxygen requires 2 electrons. This oxygen also requires 2 electrons. So what they do is they actually share these 2 electrons. They share this electron with this, and this oxygen also shares 2 of its electrons with the other oxygen. Whereas this oxygen too shares 2 electrons with the other oxygen, and they form a bond between the 2 oxygens. So basically, this is what happens, not this. So you can even depict it like this. This can also be depicted like this. So if we have an oxygen with 6 electrons, and we have another oxygen with 6 electrons. Now, basically, these electrons are going to be shared with this oxygen, so you're going to share these electrons with this oxygen, and these 2 electrons will be shared with this oxygen as well. So it is going to share these 2 electrons with this oxygen. So you can see that there are 2 electrons from this oxygen, 2 electrons from this oxygen, and between these 2 electrons there's going to be a pair of bond each, right? Now this is an example of a covalent bond, right? A bond formed by sharing. Each oxygen is contributing 2 electrons in the share, right? So that's a covalent bond. Let us take another example. Suppose I have the example of hydrogen, right? Hydrogen, we all know, H2 molecule. Now, how does it form a bond? Hydrogen has an atomic number of 1 and its electronic configuration is also 1. So it just has 1 electron in its shells, only 1 electron, so 1 electron here. Let's take another hydrogen and 1 electron here. Now, hydrogen is one of those elements which looks for a duet configuration. It cannot have an octet configuration because it has only 1 orbit, and as per Bohr's equation 2n square, where n is orbit number, which gives the number of electrons that can be accommodated in nth shell. So if we take n equal to 1, that'll be 2 into 1 whole square, that'll be 2 into 1, that'll be 2. So the first shell can only accommodate 2 electrons. That's why hydrogen looks for a duet configuration. So hydrogen looks for a duet configuration, not for an octet configuration, because it cannot accommodate 2 electrons in its outermost orbit, which happens to be the first orbit itself, right? So basically it wants to achieve a dual configuration. So it wants 2 electrons in its outermost shell. This hydrogen requires 1 electron and the other hydrogen too requires 1 electron. So again, they share 1 electron each. 1 electron shared by this, 1 electron shared by this, and ultimately there will be a bond which is going to generate between these 2, right? And you can depict this as hydrogen, right? Now let us compare the case of oxygen and hydrogen. In oxygen you can see that there are 2 electrons being shared by each oxygen, which is leading to the generation of 2 bonds. 1 between 2 electrons and 1 between 2 electrons, right? In case of hydrogen, they are sharing one electron each. So they're just forming one bond between two electrons. The kind of bond, therefore, generated in hydrogen is a single covalent bond. Single covalent bond. Whereas in oxygen, the bond generated is a double covalent bond. Since they are sharing two electrons each, and they are forming two bonds between two electrons each, right? So that is a double covalent bond, right? Now, there is even a triple covalent bond, right? Let's take an example. Now, let's take a carbon atom, a carbon molecule. CH, CH, or C2H2. You can write this as C2H2. Let's take this example. Right? Now, let us first draw the carbon. Right now, carbon configuration. Atomic number 6, configuration 2, 4. So 4 electrons in outermost shell. It's, okay, so that's it. Then for hydrogen, as we've discussed just before this, 1 electron in the outermost shell. That's it. Now let's draw the Lewis dot structure, also called the electron dot structure of each of them. Carbon. 4 electrons in outermost shell, so we're going to show 4 dots. Okay, I'm showing all 3 in this side. You'll realize why in a bit. And we'll show another carbon with 3 like this, right? And we're now going to look at the hydrogen. So hydrogen linked to this and hydrogen linked to this. Firstly, there is going to be a bond formation between this hydrogen and carbon. So you can see that this hydrogen and carbon are forming some bond, right? So they're going to form some bond here. Right? And there's going to be a bond formation between the two. Same as the case with this carbon and this hydrogen. They're going to form a bond. They're going to share their electrons. Hydrogen wants 2 electrons and carbon wants the hydrogen electron. So it's going to take that. Right? So that's between the carbons. And there's going to be a bond formation between this hydrogen and carbon. Right? Now, you can see that the duet of the hydrogen is complete. Hydrogen duet is complete. Right? But the octet of the carbon is yet not complete. But notice here that each of them has 3 electrons, right? So, to achieve that configuration, they now take and share these electrons as well. So, carbon is going to share this electron, these 3 electrons with this, and this carbon is going to share these 3 electrons with the other carbon. Right? And therefore, there will be a bond formation between these 3 electrons. Right? So if you draw the structure a bit better, which I know I've not drawn it well, there's going to be a hydrogen bond here. There's going to be 3 bonds with this carbon, and there's going to be another hydrogen bond here. Bond with this hydrogen, right? So here you can see that there are 3 electrons which are being shared. You can see that there are 1, 2, 3 and 1, 2, 3. Each carbon sharing 3 electrons, so 3 bonds are forming. This kind of a bond is called a triple covalent bond. Right? I hope that's absolutely clear to you, right? That's how a covalent bond forms. Basically, electrons are given to each other. And the sharing is a mutual sharing of electrons. You can see here they are mutually shared. Both give. Here too they are mutually shared. And here too they are mutually shared. They're given by both of them, right? So you can see that there is mutual sharing of electrons in all cases, right? So that's what we call a covalent bond. Now, let us have a look at some of the common covalent bonds, right? First of all, almost all carbon compounds are covalent compounds. Now, covalent compounds are those compounds which are formed by the covalent bond, right? So almost all carbon atoms are, carbon compounds are covalent compounds, right? Hydrogen usually forms covalent bonds. Okay? Carbon too usually forms covalent bonds. Another property, covalent bonds are weaker than ionic bonds. You will see that ionic bonds are really strong, covalent bonds are slightly weaker. Okay? They are weaker than ionic bonds. Just try to understand that ionic bonds are much, much stronger, right? So, covalent bond structures, and lastly, I'm taking covalent bond structures can be determined. Covalent bond structures can be determined through hybridization. Right? So, what is this hybridization? We will discuss hybridization in a separate series because it's a very varied topic. I'll take it up in a separate series. Okay, so these are some of the properties of covalent bonds. Almost all carbon compounds are covalent compounds. Hydrogen usually forms covalent bonds. Covalent bonds are weaker than ionic bonds, and covalent bond structures can be determined through hybridization. The actual structures, well, these structures which we are drawing, they are not actually the actual structures, these linear structures we are drawing, right? This one and this hydrogen, this one, and in the NCERT 10 standard textbook it says it is, but actually if you go in higher classes, this is not the actual structure. The actual structure is 3D, right? So with this, we conclude this video on covalent compounds. I hope you learned something. Thank you very much for joining me today. Do like and subscribe. Any doubts are welcome in the comment section below. Bye bye, stay healthy, stay smart, and do keep studying. Bye bye.